In today's lesson, you are asked to find the distance between the 2 points that are on a graph. So let's look at this graph. The 2 points they're giving you are at each endpoint. Trying to mark them the best I can. There's one there, and there's one there. Okay, notice that those 2 points are also the endpoints of a line, and that line happens to be a diagonal. So actually what we're going to use is the Pythagorean theorem to find the total length of that line, because the length of the line is also the distance between those 2 points. So the first thing we have to do is we have to draw a right triangle on the graph. Okay, you remember doing this whenever we were finding slope. We called it slope triangles. Well, it's the same thing that you're going to draw. So I'm going to go ahead and draw mine above. So I'm going to go all the way up the best I can using this computer until I get even with that line or dot, and then I go directly over it. See how it makes a right triangle? But notice, remember, I'm going to go ahead and do this one in blue. It's okay if you choose to draw yours below it, because they'll be the exact same lengths. And I'll show you that. I'm going to go ahead and count the red one first. My horizontal line, 1, 2, 3, is 3 units long, but now let's look at the blue horizontal line. It also turned out to be 3 units long. So see, we ended up getting the same number. Now do the vertical line. The red one is 1, 2, 3, 4, 5, 6, 7 units long. Let's check that blue one. When I count those units, it's 1, 2, 3, 4, 5, 6, 7 units long. So see, either way, you're going to get the same two numbers of 3 and 7. So don't worry about where you actually draw the triangle if you choose to go above it and to the right, or below it, above it and to the left, or below it and to the right. You'll get the same thing. All right, so now notice what we drew becomes the legs to that right triangle. So to find that diagonal, we're going to use our Pythagorean theorem of a squared plus b squared equals c squared. So we're going to substitute into the two leg spots, the 7 and the 3. So I'm going to go with 7 squared here and the 3 squared here, and that's going to equal the c squared. 7 times 7 is 49, and 9 times 9, or 3 times 3, I do that all the time, don't I, guys? 3 times 3 is 9. That's equal to c squared. 49 plus 9 ends up giving me 58 is equal to c squared. Now I need to take the square root of both sides, and I need to put that into my calculator really fast. I'm going to type in square root of 58, and I get 7.61. I'm looking at that 1 to choose how, oops, I don't need that square, do I? Okay, I'm looking at that 1 to choose how to round. I stay the same, so that means C is equal to 7.6. C happens to be the length of that line, which is also the distance to the 2 points. Okay, so let's kind of summarize what you're going to do today. You're going to be given the graphs with the lines on the graph. You're going to have to complete the triangle by drawing the two legs. After you draw them, count the length of each side using the boxes, then plug those two numbers into the leg positions in the Pythagorean theorem, solve your Pythagorean theorem, and you will be at your final answer.